Hi to all. This is Mahesh, Assistant Professor, Electrical Department, Institute of Aeronautical Engineering College. So today we are going to discuss network analysis subject. So in this network analysis subject, today we are going to discuss the module 1 is Introduction to Analysis of AC Circuits. So the module 1 is very clear, where we are going to discuss Introduction to Analysis of AC Circuits, which means where AC circuit is there. In that AC circuit, the first of all, the circuit means the interconnection of electrical elements. So as we know that the basic fundamental electrical elements are like resistor, inductor, capacitors. So in the AC circuit, these resistors, inductors, capacitors are going to be interconnected, maybe in the series connection, parallel connection, or any other complex connections. So these circuits, when they are interconnected, and these circuit elements are excited with AC supply, which means a sinusoidal voltage signal or a sinusoidal current signal is feeding to this AC circuit, then finally that circuit is called AC circuit or sinusoidal circuits. So the analysis of AC circuit, what does it mean by analysis of AC circuit? So AC circuit where electrical elements like R, LC parameters are interconnected, as I said, either in series connection or parallel connection, and they are feeding with sinusoidal voltage signal or sinusoidal current signal. Whenever these sinusoidal voltage signal and sinusoidal current signals are given to these AC circuit parameters, so with respect to this source, AC source, alternating current source, how these circuit parameters are going to be behave. So the behavior is very clear. The behavior of these electrical elements, which means the how much of voltage drop across taken place, and some of the elements maybe instead of dropping, they may rise the voltage. So how much of voltage rise taken place across the elements, and how much of power consumed by these elements, and we are also going to see whenever these is AC circuits. So in the AC circuit, there is some very important terminologies are there like impedance, admittance, susceptance, conductance. So the AC circuit is there. It is excited with the AC supply. So some people are interested to calculate what is the total network impedance, what is the total network admittance, what is the total network susceptance, conductance, and what is the total network power factor. And one more important point here is the AC supply given to these circuit parameters. So there is a corresponding power consumptions or would be taken place. So later on we are going to discuss different powers consumed by these different elements when they are excited with the AC supply. So these are all things we are going to deal in AC circuit analysis. So today I am going to explain the brief introduction about this AC circuit analysis. So in this AC circuit analysis, so what are the important things we require, the fundamental things. So first of all, we try to understand these fundamental things. Thereby, we can very comfortably deal this AC circuit analysis. So AC circuit analysis is very clear. It is. So circuit parameters are there. They are interconnected, which means some of the parameters may be series connected, parallel connected, or star connected, delta connected, whatever it may be the connection. So and also they are feeding the electricity. So AC electricity. So with respect to this AC electricity, so when these electrical circuit parameters are interconnected, so what is the in order to calculate these behaviors with respect to the source voltage, so again we have to have some mathematical tools. So as you know the fundamental principles of this circuit analysis nothing but same like Ohm's law and Kirchhoff voltage law, Kirchhoff current law, mesh analysis, nodal analysis, and theorems. These all are equally applicable to AC circuit also. So by using these good mathematical concepts, and we would like to apply this mathematical concept to the AC circuits, and we are going to study the behavior of these AC circuit parameters with respect to this sinusoidal voltage or sinusoidal current source. So for that, we require some fundamental basics. By understanding these fundamental basics, one can easily do any analysis of AC circuit is considered. So before going to these fundamentals of AC circuit analysis, let me explain the importance of electricity. Why? Because this network analysis subject where in interconnection of elements is called circuit or network. So where electricity is given to this network. So we have to understood what is the basic fundamental thing in this electricity. So here it is very clear. The basic fundamental thing in electricity is nothing but electric charge. So I would like to explain, or I would like to define this electrical charge. Thereby, we can understand some important concepts of electricity. So electrical charge is an electrical property of an atomic particles of which matter consists. So you all of you know that in the universe, so many matters are available. So in the matters, they are fundamentally construction by the particles, and these particles having atoms. So we know that these atoms having electrons, protons, and neutrons again. So where these electrons are available means the fundamental source for electron is atoms. So the electrical charge, the concept of electrical charge is underlying principle of explaining all electrical phenomena. So whatever the electrical phenomena taken place, the who is the fundamental behind this all electrical phenomena means strictly it is electrical charge. And so this electrical charge having one of the beautiful unique feature. Due to this unique feature of this electrical charge, nowadays we are enjoying this electricity. Thereby, we are enjoying these electrical appliances. Thereby, we are enjoying a lot of comfortness. So, what is the beautiful feature of electrical charge means? The electrical charge having the one of the important feature is called it is mobile in nature. Due to this important feature of mobility of this electrical charge, I can or we can transmit electrical energy from any place to any other place. Why? Because these electrical charges are inherently having the important feature is called mobility, which means they are capable to move from one place to any other place, but they require some external energy source. So, if we are caliber or capable to providing some external energy source to these electrons, then they are consuming that external energy and they are freely moving from one point to other point, then we can say electricity is flowing. So this is one of the important beautiful feature of electrical charge. Thereby nowadays we are generating electricity any place and we are transmitting this electricity comfortably to one place to other place due to this mobility feature. So as I said, they require some external energy. So as far as this electrical engineering is concerned, so in a conductor, electrons are tremendous. Ideally, infinity number of electrons are available in conductors. The thing is, if a conductor simply having the electrons doesn't carry any current. So if you want to see some current flowing through conductor, I must ensure that so there should be some momentum of electrons should be taken place. So in order to create compulsion or momentum of these electrons in a conductor, as I said, they require some external energy source. So as per electrical engineering concern, this external energy source which is provided to conductors, thereby this conductor having the electrons or charges or negatively charges, these charges are consuming that external energy, thereby they are comfortably moving from one point to other point. So as far as this electrical engineering terminology is concerned, the external energy which we are providing to these conductors for creating compulsion force in electrons, that external energy we are called EMF or electromotive force. The electromotive force having the different names like voltage or potential difference, which means electromotive force and voltage and potential both are one and same. The purpose of this voltage or electromotive force or potential difference is it is an energy form which is always given to the electrons which are available in the conductors. So they are consuming this EMF or voltage or potential difference by utilizing this voltage. Now they are comfortably moving from one point to other point. How they are moving means they are having the inherent feature. The feature is called mobility. So that is the reason the entire world is adopted electricity as a primary energy source. So I can conveniently transmitting electricity from one place to any other place due to it has the internal feature or inherent feature of mobility. The only thing I need to do is I have to provide some external energy source in the form of voltage, potential difference or electromotive force. So as far as this electrical engineering concerned, these external energy sources are voltage or potential difference or electromotive forces which are generating at power plants. The purpose of power plants is where an alternator is there which converting mechanical energy into EMF or electrical energy. Whatever the voltage which is built up with the alternator, the voltage is given to the conductors which are acting as a conveyors for electricity. Thereby, electricity is conveniently transmitting from one place to any other place through a conductor. So this is a basic fundamental behind the electricity. So the fundamental thing fundamental thing in this electricity is nothing but a charge. So again, this electricity is an energy source. This electricity we can access in two ways. The way one is the DC electricity or DC current. The second way is AC electricity and AC current. So what does mean by the AC electricity? So what is mean by the DC electricity or DC current? A DC current is a current. It has a magnitude. So the magnitude of the DC current will not change irrespective of the time variation. Which means as long as time pass away, the magnitude of this DC current will not be altered. It will always maintain constant. So that nature of that kind of electricity we would call DC electricity or DC current. As far as AC current is concerned, it is also having the magnitude, but that magnitude would be varying or changing with respect to time. So naturally, this AC electricity should and must varying the magnitude with respect to time function. So in general, in the universe, the kind of signals which are varying the time function is called time varying signals. So there is a lot of time varying signals are available in general, like a square waveform, a triangular waveform, a trapezoidal waveform, a sinusoidal waveform. So many time varying signals are available, even though the entire world adopted sinusoidal family members like sine signal and cosine signal as a AC current signal. So there would be a good reasons behind the selection of these AC sinusoidal signals chosen as a fundamental current signal which you are generating at alternators. Which means time varying signals, even though available in different forms like trapezoidal, square, rectangular and sinusoidal, we are adopted or we are chosen these sinusoidal family members like sine signal and cosine signal as a alternating current signals, and these signals we are generating at alternators. So why we are chosen the sinusoidal family members as a electricity signals? There is a good reason we are going to discuss. An alternating current, as I said, in alternating current is a current that varies sinusoidally with the time. As I said, we are adopted the sinusoidal family signal as a alternating current signal. So as I said, even though there are the different types of time varying signals are available, but we chosen these sinusoidal family members like sine signal and cosine signal as a or AC current signal. So we will discuss why we are chosen. So there is so many reasons are there. There is a reason we are chosen these sinusoidal family members as a AC current signal. And what is the nature of these AC current signals or AC sinusoidal signals? So such a AC current signals reverses at regular time intervals and has alternatively positive and negative values. So they are reversing their magnitudes alternatively from positive to negative, negative to positive, positive to negative, and negative to positive. So this is the nature of time varying signals or AC current signals. So I would like to draw a simple DC signal and AC signal. So here I am going to draw. So what is meant by the DC signal? DC, direct current. So as I said, electricity available, or I can access or we can access either DC electricity or AC alternating current. So what would be the DC current? As I said, DC current, y-axis is the magnitude of the current, x-axis is the time function. So as I said, DC current or DC signals having the magnitude, that magnitude is always maintaining constant irrespective of the time variation. At time t equal to 0, I would like to draw DC signal or DC current signal. It is a constant. Which means at time t equal to 0, this is the magnitude. At a time equal to this much, this is the magnitude. At time equal to this much, this is the magnitude. Here in the figure, it is very clear. In x-axis, the time goes on increases but the magnitude of the current is always maintained constant. So these kind of signals we can call generally direct current signals. So if it to the voltage, it is called direct DC voltage signal. But whereas in case of AC signals, as I said, AC signals are time varying signals or alternating current signals. As I said, these AC signals we are chosen sinusoidal family members. Sinusoidal family members. So what are the sinusoidal family members? That would be sine signal or cosine signal. So we choose in the sine signal and cosine signals as alternating current signals. We choose in and we are generating these sine signals and sine signal, sine and cosine current signals at alternators, and we are transmitting throughout a long length conductors, and we are transmitting at a point of loads where people are going to be consuming this AC electricity. So as I said, so many time varying signals are available in general, but we choose an time sinusoidal signal, sinusoidal family signal like sine signal, cosine signals as a alternating current signals. The reasons we will see. So what would be the characteristics of this AC signal? So AC signal, as I said, we choose an AC signal as, so we choose an AC signal as the magnitude of AC signal is positively increasing, reaching the zero, negatively increasing, zero, positively increasing, negatively increasing, goes on. So if it is a voltage signal, V of t time function, y-axis is the magnitude of the current or voltage signal, and the x-axis is a time function t. So from this rough diagram, it is very clear these AC signals are having the time dependent signal, which means as long as time is pass away in the x-axis, the magnitude is goes on changing. The magnitude goes on changing. So here the signal having the maximum value, it would be called Vmax. Vmax. So alternatively, why it is called alternative signal means it is very clear from here to here, positive peak, then zero, then negative peak, again positive peak, negative peak. So alternatively, the signal is going to be repeating in nature. So it is called alternating signals. So these signals having the time period t, and the signals also having the frequency. These all things, it is all fundamental. We will discuss later. But here I would like to explain. So what are the simple characteristics of DC signals and AC signals? So DC signal is very clear. It has a magnitude, but the magnitude is constant irrespective of the time variation. As far as this AC signal is concerned, it is also having the magnitude, but this magnitude very much vary with respect to time function. So that is a very important observation. So in general, these AC signals we can express in two ways. One is the argument way, other is the time function. So the things we are going to see later. So the importance of sinusoids. As I said, even though there are so many time varying signals are available, but we are choosing sinusoidal family signals like sine signal and cosine signal as alternating current signals, and we are generating it alternators, and we are generating these sine signal and cosine signals and transmitting and distributing. Finally, we are going to be consuming. So why they are chosen? Why they are having that much of importance? The things we are going to discuss in this slide. So we are interested in sinusoidal for number of reasons. So there is so many number of reasons are there, but I would like to express here some of the few important, very important reasons why these sine signal and cosine signal are adopted as these alternating current signals. The first thing is the nature itself is characteristically sinusoid. So sinusoidal signal by nature they're characteristically the sinusoidal nature. Sinusoidal means having the positive peak and negative peak, positive pulse negative pulse, positive pulse, negative pulse continuously in sinusoidal nature. The second reason is the sinusoidal signals are easy to generate and transmit. So I said so many signals are available like trapezoidal, rectangular, pulse. So compared to these time varying signals, these sinusoidal signals these are very conveniently are very easy to generate and very easy to transmit from one place to other place. The third thing is it is a form of voltage generated through the world. It is a form of voltage generated throughout the world and supplied to homes, factories, laboratories, so on. So these sinusoidal signals are generated in the entire world and they are comfortably transmitted to different load points like homes, factories, laboratories, industries, hospitals, educational institutions. So many applications or so many load points we are going to be transmitting these alternating current signals. And it is a dominating signal in communication and power industries. So as far as this communication and power industries are concerned, so these sinusoidal family signals are very much dominating as compared to the remaining available time varying signals. So this is also one of the important reason why we are choosing these sinusoidal signals as a AC current signals. The third important thing, reason behind this selection of sinusoidal family signal as AC signals is, so through Fourier analysis, any practical periodic signal can be represented by sum of sinusoids. So in order to do any signal analysis, any periodic signal analysis, we need to apply Fourier analysis. So if you want to apply Fourier analysis for these periodic signals, so all these periodic signal, when they are gone through Fourier analysis, these all periodic signals should be represented by a sum of sinusoidal signals only. So there is a convenient. So if the generated signal is of sinusoidal, so and this any different periodic signal I want to do analysis in the Fourier analysis, the resultant also represented the sum of sinusoidal signal. There is a good and comparison is availability. There is a lot of easiness will be getting. So lastly, a sinusoidal is easy to handle mathematically. As I said, this AC system, when it is subjected to a circuit, the circuit is generally called as the complex circuit. Why? Because there is a lot of parameters or complex parameters are coming to picture. So as far as DC is concerned, only simple parameter is called a resistor is coming to picture. So in entire DC circuit analysis, where resistors are acting as a loads. So whenever a DC supply is given to this DC circuit, which means resistors are going to be consuming that DC electricity. So there, if you want to do the analysis with respect to this DC supply, and the load is only the resistor, and the entire analysis is very simple in nature. There is no complexity. The power consumed by the resistor, the voltage drop across resistor, the energy consumed by the resistor, the all analysis we can do very comfortably, very easily. The reason is DC is a simple system, and the only one element resistor is going to be playing in DC. Whereas in case of AC is concerned, not only resistor, there would be two more important elements are coming to picture like inductor, capacitor. Whenever inductors and capacitors are introduced in any circuit, then the circuit will become complex circuit. Why? Because these AC electricity given to this inductor and capacitor, there would be one more important thing will come into picture. That is a complex operator J. A complex operator J will come into picture automatically whenever inductor capacitors are coming to picture. We are going to see the important word is called impedance admittance of each and every element. So the example purpose, if it is inductor, I want to calculate the impedance of inductor, that is nothing but J omega L. The J parameters come into picture. The omega will come into picture. Omega equal to 2 pi f. The frequency will come into picture. If it is a capacitor, I want to calculate impedance of the capacitor. It is 1 by J omega C. So again, this impedance of capacitor involving a complex parameter is called J operator. So due to this involvement of J operator, the system will become more complex. But if I take a simple resistor, if you would like to calculate impedance of simple resistor, it is R only. Only real part will come into picture. There is no imaginary part at all. There is no J operator at all. So where there is a J operator, automatically the system complexity will going to be increased. So the elements which are involving the circuit analysis having the J operators, obviously they are making that entire circuit will become complex circuit. So that is the reason these AC circuit analysis are a little bit complex compared to the DC circuit analysis. So for more understanding of this AC circuit analysis, first we should and must understood this J operator. By understanding properly by this J operator, we can very comfortably understood this entire AC circuit parameters. How this J operator will behave, what is exactly behavior of this J operator, if you would like to understood, then the AC circuit analysis is almost very easy. So J operator having its own characteristic. So it having its own meaning, physical meaning. So that physical meaning we can very comfortably understood by studying the graph theory in later classes. So the J operator is a complex number having the magnitude 1 and rotating in the clockwise direction up to 90 degrees. That things we will see in the later classes, which means so it should be rotating in 90 degrees. So the J operator with respect to reference, it should and must be rotating. If it is a J operator, it should and must be rotating up to 90 degrees. So it should be reaching to here 90 degrees. So here is the J operator. So we will see in the graph theory when vectors are rotating in the clockwise direction by making the angle theta, these thetas are called lagging in nature, indicating in with negative symbol. So J operator having the unity magnitude and revolving 90 degrees in clockwise direction is a property of J operator. These things we are going to see in the next classes, but this point of time I would like to give just a brief introduction. So if it is a minus J operator, it is a plus J operator and a minus J operator. So minus J operator, the physical meaning of this minus J operator means it is also having the unity magnitude. It is also having the unity magnitude, but this minus J operator is revolving in clockwise direction, till 90 counterclockwise direction till 90 degrees. So here is a minus J operator. So these things we will study. In next classes. No problem. But what is the intention here is by proper understanding of this J operator. And one more important feature of the J operator is, so whatever the parameters which are multiplied with the J operator, those parameters automatically getting the characteristics of J operator. So if any number is multiplying with the J operator plus J operator, that number or that multiplied quantity would automatically obtain the J operator characteristics. And any quantity which is multiplying the minus J operator, so that multiplied quantity would automatically obtain minus J operator characteristics. So these things, by proper understanding of the J operator, the AC circuit analysis are very simple in nature. So those things we are going to see next classes. So here I would like to introduce one more important term is called phasor. Phasor. So phasor also playing very important role to do AC circuit analysis. Phasor also playing very important role. So phasor, how would I like to define the phasor means? A phasor is a complex number that represents the amplitude and phase of the sinusoidal signals. So let me take a sinusoidal signal. Let me take a voltage signal V of t equal to Vm sin omega t plus phi. So it is a general expression of any AC signal in a time domain representation. So a time domain signal V of t equal to Vm sin omega t plus phi, or else I would take Vm cos omega t plus phi. So we know that V of t is the voltage signal, which is a time domain signal, and where this Vm is called magnitude of the V of t, and this omega t is called argument of the V of t, and this phi is called phase of the V of t. So it is a standard representation of any AC signal or it may be voltage signal. Let me take a current signal I of t equal to Im cos omega t plus phi. The I of t is a time varying current signal. So where Im is called the magnitude of the I of t and omega t is called argument of the I of t, where omega is called the natural frequency of the I of t and phi is called the corresponding phase of the I of t. So this is a representation of time domain signals. So these Vm sin omega t or Vm cos omega t are given to the AC circuit. Now we are going to see circuit analysis. So yes, we can do the circuit analysis with respect to this V of t and I of t excited to the AC circuits. But the thing is, these are involving the time function. Thereby, the circuit analysis are more complex. It will take more number of steps. It will take more time consumption. But if I am able to converting these time domain signals into equivalent phasor signals, the phasor signals is a very simple in nature. We can very conveniently do all type of circuit analysis, very simple manner. But we should and must express these time domain signals into phasor domain signals. So phasors are playing very important role in all AC circuit analysis. Reason, all circuit analysis where you want to apply some KVLs, mesh analysis, nodal analysis, network theorems, whatever it may be. So this phasor representation will give us very simple mathematical solutions for a linear circuit. Why? Because the phasor having the important feature is like it is independent of time function. That is a very important observation. So phasor, let me take, if I want to just I want to convert these time domain voltage signals into equivalent phasor signal. So V of t will become phasor capital V. As I define, the phasor is very simple. The definition is very clear here. The phasor is a complex number. Yes. So we are going to discuss the complex numbers we can express in three important ways. That is rectangular representation, polar representation, and exponential representation. So most of the electrical circuit analysis, we prefer rectangular and polar representation. This exponential representation is not considered due to a more complexity. So phasor is a complex number. Yes, it is a complex number, means it would be maybe the rectangular or polar representation, and it represents magnitude and phase of the sinusoidal signal. So in this example, V of t equal to Vm sin omega t plus phi, I would like to convert it equivalent to phasor. So phasor V, capital V. So phasor is a complex number. It is having the magnitude Vm at an angle, phase angle of the time domain function. The simple representation of time domain to phasor domain. The very important observation from here to here is time domain V of t, the function of time, capital V does not having any time function. That is one of the biggest advantage. Phasors will not involve with respect to the time function. That is one of the important feature of phasor. Phasors are very simple in nature. They are having only the magnitude of the time function and only having the phase of the time domain signals. Very convenient. Suppose I would like to convert these I of t time domain signals into phasor representation. As I said, I of t will become capital I or phasor current. Phasor is a complex number having the magnitude where I of t magnitude is Im at an angle. It having the phase angle of I of t is phi. It's a very simple representation. So I of t equal to Im cos omega t plus phi. Application to the any electrical circuit for analysis. First, we would like to converting all time domain functions or signals into equivalent phasor signals. Why? Because these phasor signals does not having any time function. That is the reason once you converting these time domain signals into their equivalent phasor domain signals, now the analysis are very simple and very easily we can do circuit analysis for a linear circuit is concerned. So, and some important phasor conversions. Suppose in time domain function I am having the derivative function d by dv of t by dt, dv of t. So this function, if I want to convert into phasor, it is j omega into v, which means any time domain signal having the derivative. So this derivative we would like to convert into equivalent phasor. So we should and must multiply j omega with corresponding phasor voltage. Suppose it having the integral v of t. So any integral in time domain, I would like to convert into equivalent phasor domain. So it will become 1 by j omega into phasor v. So these two are very, very important for AC circuit analysis. So any function, any time domain function, if it is in the form of derivative function, I would like to convert into equivalent phasor representation. That particular function phasor must be multiplied with j omega. Any time domain signal which is in integral, so the integral of time domain function, I would like to convert into its equivalent phasor function. So that particular phasor quantities must be multiplied with 1 by j omega. So these are very much important for us to do the AC circuit analysis. And as I said, these phasor is a complex number. This complex numbers we can express, general complex number z we can express in three ways. As I said, a rectangular representation z equal to x plus jy, a polar representation z equal to r at an angle phi, and exponential expression z equal to e to the power of j phi. So these three forms are equally valid for AC circuit analysis, but mostly we are prefer rectangular and polar representation. And particularly addition subtraction of two complex numbers are considered. We prefer in rectangular representation, very convenient. And multiplication division is considered about two complex number. These polar representations playing very, very important role. So this is some basic fundamentals in AC circuit analysis consider. And as I said, time domain signals must be converted into equivalent phasor domain signals. Reason is the phasor domain signals are independent of time function. So that is another important reason. So they are independent time function. That is the reason. Once we convert into time domain signals into equivalent phasor domain signal, then we can do conveniently, very easily all circuit analysis like calculation of network total impedance, calculation of network total admittance, calculation of network total complex power consumption, total active power consumption, reactive power consumption, apparent power consumption, and we can draw comfortably that equivalent power triangles of any circuit is considered, or any particular portion power factor also we can calculate very comfortably by understanding of these fundamentals in case of AC circuit analysis considered. So in the next class, we are going to see how to define the impedance, admittance. Some important definitions are there we are going to define. So simply speaking, the impedance is a phasor ratio. Z impedance of any element is a ratio of phasor voltage. It's a ratio of phasor voltage to phasor current. These are not simple voltage to simple current. It's a phasor voltage to phasor current. Where phasor voltage equal to, I said, Vm at an angle theta v. Phasor current equal to Im at an angle theta I. So finally, the impedance is defined as Vm by Im at an angle theta v minus theta I. So a network is considered. I would like to calculate the network power factor, the complete network power factor. So that complete network power factor is also equivalent to the complete network impedance angle. So how this complete network impedance angle and the complete network power factor angle one and same, the thing also we are going to see in our next classes. So this is some introductory regarding this AC circuit analysis. In next classes, we are going to see the important terminologies like impedance of the network, admittance of the network, and susceptance, conductance, and power factor, and the complex power, active power, apparent power, reactive power, and whenever R and L parameters are in series connection, how they are behavior with respect to AC sinusoidal, and R and L are in series connection, when they are excited with the AC supply, how they are behavior, and R and L and C, 3R in series connection with respect to AC excitation, how circuit would behaves, and R and L and C parameters are parallel connection, AC supply is given, how they are behavior. These are all things we are going to study in the first G module. So with this, I would like to conclude. Thank you to one and all.
Like, share and subscribe. Hit the bell icon for more updates.